So if you calculate the value of u2 and u3 and u4, you will get this is equal to simply 5.76 and 7.68 multiplied by 10 to power minus 5. Okay, and this is a meter. Okay, so this we got. Now we know that our u is basically we had first one 0, last one is 0, sorry, first one 0, second one 0, third one is 5.76, so 5.76, and then 7.68, 7.68, and 10 to power minus 5 meter, and that tells you 0 here, 0 here, in the middle the here you have 5.76 10 to power minus 5, and here you have 7.68 10 to power minus 5, like this one. You know that here what you have assumed is a linear is a quadratic shape function, so tile function was quadratic, so this is how it is going to change quadrate, the u will be quadratic, here it will be linear. So if you want to plot it, this will go like this. So this is u, right, ux, and this is x, and this is x equal to 1, this is x equal to 5, in the middle you have x equal to 3. It will start from 0, yeah, so 0 at this end, 0 will be also at this end, and you have some value 5.7, so a lower value which will be here, and yeah, and then you will have some value here like this one, yeah. So or rather just to exaggerate, we can have even little bit lower, so that this is just little bit up, yeah, so we will go like this, we go like this one, yeah. So we can plot this will go like this, yeah, okay, and then this will come to 0, yeah, so this will from 1 to it will be 0 like this, yeah, this will linear. So okay, maybe we use different color, so let's see, green from here to here, okay. So this one is linear, and this one is quadratic. Okay, so this is how it will look like. Now you can also find out the strain. The strain will be the strain you can plot, right? So simply it will be the slope. Yes, this is the, you can find out the slope, and accordingly you can find out what you see here. Slope is negative, hence the compression stress will be compression, and there will be a linear line here. And this case what you see is a positive slope, right? So hence the strain will be positive. So what you get here, some value which will be in slope is more here, and this is reducing like this one, so you will have some kind of this kind of thing, and then you will have negative like this. So either if you see from the curve you can find out, or you can, if you want the accurate means based on the your results also you can do it. And you know that in the first element number 1 you have u values, right? So you have u u11, u12, u13, and you know the first one is 0, then 3 and 4, so you have 0 and then this and this, so you have 0, then 5.76, 7.68, 10 to the power minus 5, yeah, and n, the du over dx is the strain, and you know this is equal to dn over, so this is summation dn I over, you can say d xi and then times u 1 I, right, and I equal to 1 to 3 in this case, and n values we have to use, right. So our n values was, so n1 actually we derived also, so n1 xi was 1 over 2, then xi, and then we have 1 minus xi, right. Okay, or we use xi minus 1 probably, yeah, so xi minus 1, so we have minus 1, so these are like that, so dn1 over d xi, and we got that was xi minus half, yeah. Similarly we had dn2 d xi was 1 minus xi square, so minus 2 xi, and 1 minus xi square, so at xi equal to 0 you have one value, so that's correct. Then dn3 over d xi was xi plus half, this is because the value will be xi plus 1, so you have d xi plus half here. So you have these values, and hence du, from here you can find out that strain over du over dx will be equal to simply like this, xi minus half minus 2 xi plus half, and then you have these values 0, 0, 5.76, 5.76, and then 7.68, 7.68, okay, multiplied by 10 to the power minus 5. This is the strain. So depending on the xi, it is going to change, yeah, where xi moves from minus 1 to plus 1 within the element. This element number 1 is goes like this, yeah. So this will be a linear combination of this one, so this multiply with zeros becomes 0, so actually you can exactly write how E changes, epsilon changes, so epsilon equal to will be 10 to the power minus 5 multiplied by, yeah, 7.68 multiplied by xi plus half minus 2 times 5.76 multiplied by xi, rather just write xi only, yeah. So this is the value of a strain as a function of xi changes from minus 1 to 1, so basically, or you can write as x changes from 1 to 3, and you get a strain like this one. Yeah, so accordingly you can plot a strain actually, and once you know the strain, you can have a stress. So stress equal to nothing but E times a strain, and E is nothing but 2 to power 10 to power 7, so you get 20. So will be, you can write just 20 multiplied by 7.68 xi. This also you can work out actually, exact value you can find out. So you can see here this is 20 here, 7.68 xi, and you have this one minus this much. So accordingly we can work out how exactly it is doing. So what we see here is some value here which will be half of this. So half of this will be 4, and then we have 8.3. okay, so 3.84, then it will be minus value of this. So what we have here is 2 times this minus 2 times this minus this, we write in minus. So we have 10, we can, let's do here. So 2 here, sorry, so 2 this multiply 2 will be 2 here, then we have 5, and then 11. Okay, so 11.52 minus 7 minus 7.68 okay, so minus, so what we get is 4 here, then we get 8, and then we get 3. So this we get 3.84. What we get? Minus 3.8. Okay, so we get minus 3.84. Sorry, so we get exactly so 3.84 multiplied by xi. Yeah, so basically sigma we get some interesting value. Sigma equal to then you can multiply by 20, so this becomes 338.4, and 38.4 is nothing but 76.8. So we get 76.8 multiplied by 1 minus xi. Okay, so this is Newton per meter square. So this is what the stress you get, and this varies from xi minus 1 to 1. So if you plot, sigma for the first element will go from some value, so you have minus 1 here, so the 2 and 2, it will go to 0. So at xi equal to 1, we have 1 minus 1 which will equal to 0, so it will go and it will be equal to 0 till then. Yeah, okay, so our value within that will go, this is linear, so value go like this. So here we have 153.6, okay, Newton per meter square, and here you put xi equal to 1 here, this becomes 0, so this value will be 0 here. Okay, so this is how changes in the first element number 1. Okay, and similarly you can have in element number 2. Okay, element number 2 we have similar thing. We have a strain will be equal to I equal to 1 to 2 n i's, again xi and u 2i, right? Okay, and the value, the dn over, so we have equal to where, so basically our value in that is we have two elements, two shape functions, and that varies. If you remember, we had n1 xi, it varied 1 minus xi over le, le equal to 2, and hence dn1 over dxi was minus half. So what we get here is minus half and half, basically. Yeah, so this transpose and multiplied by u1 u2, so our values u1 u2 is nothing but, if you see the element, we had like this one, and the other end is fixed, so number 2 is fixed. Number 1 is the same value as the u4, right? So this is the u4 basically. Yeah, so the u4 is this 3.76. okay, so we have basically half. Okay, now this will, so if you transpose this one, this becomes minus half and half here, so u4 will multiply to this will multiply to this, so basically we have negative value only, this multiplied by this 0, so it becomes minus half u4, right? So this is minus u4 over 2. Yeah, and u4 is 5.76, and also we have minus sign, has to be minus sign because of this minus, so minus 5.76. okay, 5.76 10 to power minus 5 divided by 2. Yeah, so which is equal to minus, and this becomes 8, and then this becomes 3, this is 3, then 8, and we have 2. Okay, no, there's some problem, sorry about that. So okay, so half of this one we want, so we will have of this, so it has to be 8 first, so 8 times 2 is 6, and then and then we will have a not 3, 8 again, and then 2.88. okay, so let's see, 8 times 2 is 6, 8 times 2 is 6, plus 1 becomes 7, 2 times 2 is 4, and 1, so 2 minus 2.88 10 to power minus 5 is the strain. Okay, this is the strain, and which is a constant. What you see is it does not change with xi. Yeah, this is a constant value, it's a negative. Yeah, okay, this is a strain. So stress is you multiplied by E, you get the stress. Yeah, so we will write here only. So let's write in red. So sigma will be E times a strain, and E is 2 to power 2 to power 7. So we get minus uh, 57. So here 10 to power minus 10 to power 7, if you multiply, you get 100 out of it. So uh, you, you have 100 here. So 288 multiplied by 2. So we get um, simply minus 576 Newton per meter square. Yeah, so the value we will get here will be if you plot it, this will be here somewhere like this one. Yeah, so it will go like this, where the value of this will be minus 576 Newton per meter square. Okay, so the stress will be linearly varying in the first element. In the second one, it will be constant, which will be the value of this value will be the strain. Now I see there may be some mistake, so let's correct that. So here these are minus 576. Here also it should be 1536 probably. Okay, it will go up. Why? Because of where E is given like this one. When we multiply this with E is 2 to power 2 times 10 to power 2 times 10 to power 7. Okay, so if you multiply E here, 2 times 10 to power 7, so this should be 200 instead of 20 here. Okay, so I think you have to correct it. So we will correct it. So we will say multiplied by 10. Okay, so coming from, it should have been 200. So because of that, I'm writing this. So E equal to 2 times 10 to power minus 7 Pascal. Yeah, okay, and because of that, correction will be, we have to multiply it by 10 basically. Yeah, and here also this should be multiplied by 10. So this value should be 1536 Pascal, and this value then is fine, minus 576 minus 576 Pascal is fine here. Okay, so that means the stress will change final along the whole structure. It will first go from here to here, and then it will go something like this throughout. Okay, so the value here will be 1536 Newton per meter square, and here will be constant value minus 576 Newton per meter square. Yeah, so this will be plus, this will be minus. Okay, so this is what the stress it will show. So actually we have found out everything that is required in that question. Additionally, we can also find the value of reaction forces, right? So we have K times U equal to F. Yeah, so where F was R1 here, and then we had some value, so we can check that out. So here it is. So R1 plus 10 over 3, then R2, and then this and this. Okay, so if you want to find out this one, so we have k multiplied by u values, and accordingly we can find out. So we have this k multiplied by 0 0 u3 u4 we have found out equal to f1 and f2, where f1 is equal to 10 over 3 plus r1, this r2, right? Okay, so we can accordingly we can write the values r1 plus 10 over 3, okay, and then we have r2 value, and then we have r3 and r3 f3 and f4, f3 and f4 that we had the value to begin with, yeah, and we had u as 0 0, and then we had two values 5.76 and 7.68, 5.76 and 7.68. Multiply by 10 to the minus 5. Okay, so meters. So we have u this one, and then we have the k values. So if you see here, the value of k multiplied by, so here, so this is 0, this is 0, we have to find out 10 over 3 plus r1 is there. Okay, so we have to find out r1, this is r2 is there. So in order to find out r1 r2, this will go 0 will multiply by this will multiply by 0, and then u3 to this one, u4 to this one. So we have e multiplied by simply this multiplied by this one, yeah, will be this and this. So we have this equation. So which equation will have, so we can same thing, we can write it, okay, so minus e minus 0.8 over 6, 0.1 over 6 minus 0.75 multiplied by this, and this will be f1 and f2. So basically we can find out, we can write the same equation here. We have 10 over 3 plus r1 and r2 will be equal to e times minus 0.8 over 6, 0.1 over 6, 0 minus 0.75, okay, and then we have to multiply it by u3, so 5.76 and okay, and then we have u2 value, the u4 value, so u4 is 7.68, so 7.68, okay, and this is 10 to the power minus 5. So this is how we can find out r2. So we multiply r1 will give you by solving this problem. So r2 will be e, we put e here, and this, so this will give you r1 and r2, yeah. From here we can get r1 and r2. So r2 for example will be equal to, on the second, so we are going to multiply this multiplied by this one, so this multiplied by 0, this multiplied by 7.68 minus a, so we get r2 r2 equal to minus 2 times 10 to the power minus, so let's multiply already. So this one e 2 to the power minus 2 to the power 7, so this and this becomes 200, so 200 equal to 200 multiplied by so we have this multiplied by this, so this will be 0, this multiplied by right minus, it will be minus here, and 0.75 will be there, then 7.68 will be there, 68. Okay, so this will be in Newton basically. So whatever value you get Newton. Yeah. Okay, and similarly you get value of R1 as well. Yeah, so R1 will be equal to, so you have this, so 200 multiplied by, and then this multiplied by this multiplied by this, minus 10 over 3, so you get 0. I can write this, so 0.768 divided by 6 minus 0.8 multiplied by 5.76 divided by 6. Okay, so this basically this multiplied by this multiplied by this one, E already is multiplied by this one, and minus 10 over 3. So we write here minus 10 over 3. Yeah. So this will be R2, this will be R1. Okay, so you can calculate this value, you can find out. So if you calculate R1 and R2, R1 will be minus 131.33. So let's write it. So based on these calculations, R1 is equal to minus 131.33, and R2 if you calculate becomes minus 1152. Okay, so in newtons. Okay, looking at this, I can say that there is something is wrong. So it's actually a good idea to compute R1 and R2, because this tells you that the reactions have to be equal to total force. So if you look at the problem, so it says like this one, right? So you have here, which is B, which is given as 10 Newton per meter, and there are 2 meters. So total force because of the body force becomes 10 times 2, that's 20 Newton, and then you have a concentrated load here, which is P equal to 150 Newton, right? So that means total force, total applied force will be equal to 150 plus 10 times 2. Okay, so that makes it 170 Newton total. If you see the reaction, however, you get R1 plus R2 is equal to, if we add them, what do we get? We get 33, then 3821. Okay, Newton. So see, the reaction forces are much bigger than applied force, though something is wrong. Yeah, so R1 plus R2 not equal to or far greater than, you can say, right? Far greater than 170 Newton. Something is wrong. Okay, so that means we made some mistakes. We have to go back and see. Okay, so we most likely that was when we calculate u. So okay, so if you see, okay, yeah, so when you invert it, you have to actually be careful. So we invert it, and then we have to also divide it by the determinant of this, right? So here we have to make correction. So we had this equation multiplied by this equal to this. So when this equal to inverse of this, so here it will be fine. Only thing is, what we did was interchange this one, opposite sign here, and then we have to also divide it by the determinant of this, and this we have not there here. Okay, so we have to divide that by determinant, and what is the determinant? If you determinant will be this multiplied by this minus this multiplied by this. Okay, so determinant, let's write it as delta, where delta is equal to 5.2 multiplied by 1.6 minus 0.8 square, and if you calculate, you will get this to be 7.68. Okay, that means we have to divide it by, our this one is not correct. That means we have to divide it by 7.68. So let's divide by 7.68, and hence we get value. Everywhere we have to do that correction. It has divided by 7.68. So we have 7.68 here. That means u4 is equal to 1 to the power minus 5. Okay. So this correction we have to make, divided by 7.68 everywhere. So this one, for example, has to be 7.68. Yeah, here everywhere this has to be 7.68 divided by 7.68, 68, and so on, like that. Okay, then here also divided by 7.68, and we have to do all the correction. So here also, here we have to divide, because we have u multiplied in a strain, so divide by 7.68. So 7.68. okay, and here also your sigma will also have divided by 7.68. fine. Okay, same goes here, 7.68. okay, 10 divided by 7.68. okay, so the value this will not be correct. Yeah, so yeah, again this will not be correct. You have to divide by 7.68. okay, so make like 7.68, and here also we will, let's cut this one like this one, and this will be minus 576 over 7.68 Pascal. Yeah, here 7.68 multiplied by 1 over 7.68 will be, okay. Yeah, okay. Okay, so we will get the actual values. So similarly for second one, also we have to do the same thing. We are using the same u, so we have to divide by 7.68. okay, so multiplies by 7.68, so you have to divide. So divide, maybe not, so let's have here 1 minus 1 over 7.68. Okay, so this is strain, so here divided by 7.68, and then we get R1 and R2, which will be divided by 7.68. I know 7.68, and then R1 and R2 will be divided by 7.68, and so now what we will find is the value will be a little bit different. So R1 and R2 after correction, so we found out, wherever we find out this value, there also let's go and so here R2 and all, so we have to find out R2 and R1 is basically is wrong. So basically, so 7.68 times R2 is like this, similarly 7.68 R1 will be this value. Okay, not that, because we also have this multiplied here, and all the errors are in this one only, so we can not write like that. So somewhere here we should have 7.68. Yeah, so okay, so this correction here divided by 7.68, and here we can write like this, R1 equal to, and then we say multiplied by 7.68. Okay, so that way we have R1 equal to 7.68 multiplied by 200, and like this, and minus like this one. So we did all this correction. Okay, sorry about that, but you know, I was not careful, and hence you have to be careful. So working out all those things. Yeah, so finally, but we have corrected finally. Okay, and that happened because of we checked the end forces, although it's not given, it's not required, but still you should do, always you should do. So now with correction we get R1 plus R2 equal to this divided by 7.68, and if you find out that value, then you will get R1 R2 equal to 167.1. so R1 and R2, so R1 plus R2 are equal to 167.1 Newton, and this is the new value. Okay, and we calculated applied force is equal to 170 Newton. So applied force, whereas the applied force equal to 170 Newton. So still we see the difference. So if you see from where it is like this, we can also find out R1. R1 is basically 130. The new value will be 131.33 divided by 7.68, and we get 17.1 simply. So we have 17.1 Newton, and R2 we have 1152 divided by 768 7.68 that is equal to 150. So we have this 150 Newton. Okay, so basically the if we draw, and how we get is something like this. Okay, so what we are getting is R1. Okay, we have to also see the sign, so both of them is minus, so R1 and R2 will have minus sign, so this is a minus sign. Okay, so what is mean is this minus sign here. So we have R1 this and R2 this. Yeah. Okay, so minus sign. So what you see here, R1 equal to minus 17.1 Newton, and R2 is minus 150 Newton, and then you have P, which is given to be P equal to 150 Newton. Okay, and then you have this body force. So the body force is divided basically, right? So what we see is at 3 nodes we had 10 over 3 here, 40 over 3 here, and 10 over 3 here. So we had total 20 Newton divided at these points. Yeah, so total what we see, there is a difference of 3 basically. Yeah, so we should get here. So this is divided into 3 basically. So what we got is 10 over 3, 10 over 3, so 3.33. So we get here 3.33. Okay, then here you got here also you are getting 10 3.33. Fine, and at this location you had 4 times that, so 4 13.33. So this was 13.33 all Newton. Okay, so still what we see is this force, this R1 and R2 is not equal to all of them. What we see here, this R1, these reaction forces, we get 167, and this way we have this 20 plus P, this 170. So there is difference of about 3. So again there is some silly mistake we did, so we have to look at it. Okay, so most likely that happened because we scaled it, we just said divided by 7.68. However, this one end is this is we cannot scale directly like this one. So let's go back where we calculated. So okay, so this is here we calculated like this is like R1 and R2, and then we put this scaling right here. So this works for R2 because this does not have any constant term, so accordingly this is scaled, so this is fine. For R1, okay, I think 7.68 should be multiplied to R1, not to this one, so it should be 1 over like this. Okay, so here this should be 1 by equal to 1 divided by 7.68 and then multiplied by these 200, all those things. Okay, so we have from here to here and then minus 10.6. so if you calculate this one, R1 here, actual value is actually 20. So R2 R1 is, if you calculate like this one, the value is 20, exactly 20. So R1 is this is not correct. Okay, so this one we got just by dividing it by 7.68 like this one. Okay, so R2 is correct because there is no constant term, so we will say R1 is correct, but R2 is not correct. Okay, so we will see here, so R1 is not correct. So R1, if you calculate from the new formula, the formula given there, you will get this will be 20 Newton. So basically finally the correct value we get, you will see that R1 equal to minus 150 Newton and R2 equal to, sorry, R1, oh no, this is not correct. Okay, so R2 is equal to minus 150 Newton. Okay, so like this. And which is equal to, so if you see, which is equal to the applied load, which is of 150 plus 20 equal to 170 Newton. So this is matching now, hence the results will be correct. Okay, since we did the corrections, we have to now final plots. Okay, the correct values we have to give. Okay, so correct values we have to find out, and start with u1 u2. Okay, so our correct values, let's write final value, correct final values will be, u will be equal to 0 0, okay, and then it will be 5.76. so we have 5.76 divided by 7.68, so 0.75. so we have 0.75 and 1, okay, multiplied by 10 to the power minus 5 meters. This is the answer. Okay, u will be like this one. Accordingly our stresses, the if you draw it, will be like this. So here, okay, so this is x equal to 1, x equal to 3, x equal to 5, this is x equal to 2, the values 0, it will go from 0 to 0.75 to 1, okay, and this will go like this, okay, and then from there to end, this will go a straight line, go like this. Yeah, so this is what the u will look like. Okay, and then we have to find out the stresses. So sigma, okay, sigma is this, so sigma is this one in the first element, so this is 76.8 divided by 7.68, so this is 10, this is 10 multiplied by 1 minus 10 here and then 10 here, so 100 multiplied by 1 minus xi is sigma, so you say sigma 1 equal to 100 1 minus xi, sigma 1 is like this one for xi varying between plus 1 to minus 1, and sigma 2 will have, let's see, the next one only, sigma 2, so this is sigma 1, sigma 2 is here, and this is given by this, so 5.76 divided by 7.68, 0.75 basically, so this is a strain basically, so this is here, so you have sigma equal to, okay, so actual sigma will be divided by, so we also have to scale here, we forgot to divide by 7.68 because that was the mistake we made, so we said divided by 7.68. Yeah. Okay, so that means it will be around say 775 0.75 multiplied by 100, so will be 75. Okay, so this will be around 75, so 576 divided by 7.68, so we get 75 Newton per meter square. Okay, so sigma 2 will be 75 Newton per meter square, this also will be Newton per meter square, this is valued for x, that's the global values from 3 to 5, that is x greater than 5, sorry, greater than less than 3, greater than 1. Okay, so sigma we can plot now, the sigma will be like this, so from here to here goes like this, and he have x equal to 5, x equal to 1, x equal to 3, x is equal to 2, like that, and okay, if you see this value, this goes from xi equal to minus 1, so minus 1 plus, it becomes 200, so start from 200 and goes to 0, so from 200 to 0. Okay, so this goes from 200 to 0 like this, so this one is 200 Pascal. Okay, fine, and then 0 here, and then stress will be 75 here. Okay, so let's use that, and then we have from here to here this, yeah, and the value is 75 Pascal, and this is minus value, and this is plus value. Okay, so write minus here. Okay, so this is how the states will change here. Okay, so we have solved, and also we checked whether the results are correct or not, and the best way to check is to see whether all the forces are equal to all the reaction forces or not. All the applied forces has to be equal to all the reaction forces. If you get that, then your results are fine. Okay, so we took a long time to solve this, almost not almost, but actually more than 3 lecture hours. But the idea was to sum up all the chapter 3, 4, 5, so that whatever we learned, everything we applied in solving the problem. Okay, so that way we actually the completed the whole process. Okay, so everything we connected together by this one. Only thing remains now is how to apply these to different other kinds of problem. Okay, so for example, heat transfer problem and others. So that we will do during the live session. Okay, so that is all.